Now we'll start our work on probability distributions by just revising the types of data. And that's because it'll help you understand what we're going to tackle this year in year 11 and what we're going to come across next year in year 12. Now data can all be divided into categorical or numeric data. Obviously categorical data is when you've got categories, so we might be looking at, say, the colour of all the cars out there in the car park, or I might do a survey on what house everybody in this class is in, and the answers will be things like Mawson, Dobell, Ujaroo. They won't be 1, 2, 3, 4, so they're categories. Numeric data is made up of numbers. Now, what type of numbers? Well, if you struggle to remember the difference between discrete data and continuous data, I like to remember discrete is generally things that you can count. 1, 2, 3, tends to be whole numbers. And that meaning of the word discrete means closed in and sort of contained. An individual, you have individual discrete items. Continuous data just runs on and it has an infinite number of in-between points. So I like to think of this as the numbers that you get when you measure something. So if you ask how tall I am, I might round it off and say I'm around about 171 centimetres. Now I'm going to the nearest centimetre there. So you might go, hey, what about to the nearest millimetre? So we might get out a better measuring tape and find that I'm actually 171.2 centimetres. Somebody else might say, that's not accurate enough for me. I want a really accurate measuring tape, and I'm going to actually do this to even more decimal places. Now, where do you stop? The limit with how our data looks is really dependent on what we use to measure it. And so you get to a point where you say, look, it doesn't really matter how many decimal places come in here because it starts to lose meaning. Perhaps I wasn't even standing up straight, and it's getting silly. But the fact remains that data that can be measured is really going to look different depending on how you measure it. And that's quite different from discrete things. If I ask how many students are in the class right now, there might be exactly 12. There's not going to be 12.3. It's 12 or it's 13 or it's 11 or it's 15 whole numbers. And that data looks different from the data that's been measured because the measured stuff is almost always, to some extent, rounded off. Now, how does this affect our probability distributions? Well, if I asked a question like, okay, I'm going to toss a coin 4 times, what are the chances that I'm going to get 3 tails? We're dealing with discrete data, and so all of the options are discrete. They're whole numbers that are nice and easy to categorise. And in fact, I can come up with a table there of saying, these are the things that I could get: 0 tails, 1 tail, 2 tails, 3 tails, or even 4 tails. And then I can come up with the probability of getting each of those. Next year in year 12, we'll look at the same sort of idea, but with continuous data. Now, how would you ask a question using probability with continuous data? Well, what if I said, okay, I'm going to walk to the train station and wait for a train. I know that there's one coming every 15 minutes. What's the probability that I'll be waiting exactly 9.5 minutes? Well, now we're measuring time. And how accurate is your stopwatch? What about if it's 9.5 minutes plus 0.05 of a millisecond? You get into that awkwardness of continuous data. So we're leaving that for now. We'll come back to it in year 12. So for year 11, our probability distributions will all look at random experiments where the outcomes, or the possible outcomes, are discrete numeric data.